Have you ever seen the largest star in the universe? It's so massive, it could fit 10 billion suns inside. Even light, traveling at its incredible speed, would take 8.5 hours just to circle it once. This star is called Stephenson, 218. But just how enormous is it, really? Let's dive in and find out first. Let's start with our home Earth. Earth is the 5th largest planet in our solar system. About 71% of its surface is covered in water. It's the only known planet in the solar system that supports life. It has an average diameter of about 12,742 kilometers, around 7,917 miles. The equator is about 43 kilometers 27 miles wider than the polar diameter. Earth is slightly flattened at the poles and bulges a bit at the equator. It's not a perfect sphere. Its mass is roughly 60 trillion tons. Now, 780 million kilometers, about 484 million miles from Earth, is Jupiter, the largest planet in our solar system. Jupiter's diameter is about 140,000 kilometers, 87,000 miles. It could fit over 1,300 Earths inside. Jupiter was also one of the first planets to form, growing by pulling in massive amounts of hydrogen and helium from the surrounding space, eventually becoming this gigantic gas giant. At the heart of our solar system is the Sun, a star of staggering size and mass. Based on the latest astronomical data, the Sun's diameter is roughly 1.39 million kilometers, 864,000 miles. That's 109 times larger than Earth's diameter. To put that in perspective, if Earth were the size of a ping-pong ball about 1.5 inches or 4 centimeters across, then you could fit more than 1.3 million Earths inside the Sun, tightly packed. Pretty mind-blowing, right? But compared to the largest star in the universe, Stephenson 218, even the mighty Sun seems like a grain of sand. Stephenson 218 is an extremely massive red hypergiant star, first discovered in 1990 by American astronomer Stephenson. It lies near the Stephenson 2-star cluster in the constellation Scutum, about 20,000 light-years away from Earth. Its diameter, a staggering 3 billion kilometers, nearly 1.9 billion miles minus 2,159 times the radius of the Sun. To give you an idea, traveling from one side of this star to the other would cover a distance equivalent to the gap between the Sun and Uranus. We all know that the speed of light is the fastest in the universe, about 300,000 kilometers per second, 186,000 miles per second. But even at that speed, it would still take 8.5 hours to complete just one loop around Stephenson 218's equator. If you placed Stephenson 218 at the center of our solar system, it would swallow up everything inside Saturn's orbit. It could fit an astonishing 10 billion suns inside. That's a size so immense, it's almost beyond comprehension. Imagine if Stephenson 218 were the size of a 20 cubic meter shipping container. In comparison, the Sun would be like a tiny grain of rice inside that container, because it's located 20,000 light-years away, and with vast clouds of cosmic dust blocking our view, we can't directly observe Stephenson 218 from Earth. Even though it's about 10 billion times the size of the Sun, its mass is only about 18 times greater than the Sun's. Why? Because Stephenson 218 is nearing the end of its life cycle. Heavy elements like titanium are fusing in its core, releasing enormous amounts of energy and forcing the outer layers to expand. That's why it has such an inflated size compared to its mass, kind of like a puffy giant of the star world. Scientists believe that someday, Stephenson 218 will expand to the limit, just like a balloon being blown up too much, and then explode in a spectacular supernova. The explosion could shine 100 million times brighter than the Sun. When that happens, we might actually see an incredibly bright spot in our night sky, even from Earth. Even a star as powerful as Stephenson 218 will eventually meet its end, and in the vastness of the universe, our planet is nothing more than a tiny speck. The best we can do is to cherish every moment we have here on Earth.